In this video, we're going to deal with the half-angle formulas. The half-angle formulas are derived from the double-angle formulas, but instead of putting sine squared theta in there, what we're going to do is we're going to put in theta over 2, okay? And when you do that, it becomes 1 minus cosine theta over 2 instead of cosine 2 theta. And then cosine squared theta over 2 is 1 plus cosine theta over 2. And tangent squared theta over 2 is 1 minus cosine theta over 1 plus cosine theta. So that's why it's called the half-angle identities. We're literally cutting it in half. So this half-angle identity, sine theta over 2, is equal to plus or minus square root 1 minus cosine theta over 2. Now, where did the plus or minus and the square root come from? If I square root both sides, okay? That's where that's coming from. Cosine theta over 2 is plus or minus square root 1 plus cosine theta over 2. And then tangent theta over 2 is plus or minus square root 1 minus cosine theta over 1 plus cosine theta. Okay, so the plus and minus sign is determined by the quadrant of the angle theta over 2. Okay? So those are my half angle formulas right there. All right, so I want to use a half angle formula to find exact value of the cosine of 15 degrees. Okay, cosine of 15. Now, what do I know about cosine 15? Well, that's half of 30. So cosine 15 degrees is 30 over 2. So I'm just going to utilize the formula for cosine of theta over 2, where theta is equal to 30 degrees. And so this is going to be plus or minus square root 1 plus cosine 30 degrees over 2. Now, with 30 degrees, if I take 30 degrees, divide by 2, that's 15 degrees. Where is 15 degrees? 15 degrees, this goes to 90 degrees, right? And that's 0 degrees. So 15 degrees is in quad 1. So that means that all students take calculus. Everything's positive in quad 1, so I'm going to use the positive square root there. So now, what is the square root? Now, what is the cosine of 30? That's square root 3 over 2. So this is square root 1 plus square root 3 over 2 divided by 2. So what does this equal? All right, what's that equal? That's going to be 1/2 plus square root 3 over 2. And then the other 2, that makes it 4. Okay. If I get a common denominator, I can do that. That's going to make it square root now 2 plus the square root of 3 over 4. So this is going to be square root 2 plus square root 3 over square root 4. which is the square root of 2 plus the square root of 3 over 2. Okay? So this is the exact answer for the cosine of 15 degrees. So the cosine of 15 degrees, which is equal to, in radians, well, pi over 6 would be 30 degrees. So 15 degrees would be pi over 12. So the cosine of pi over 12 is exactly square root 2 plus square root 3. Square root of 2 plus square root 3 over 2. Okay? Half angle right there. Let's do one more. Make sure we got it. So let's do the sine of negative 15 degrees. Now, the sine of negative 15 degrees, I can actually apply the odd property, which means that if the negative's in the argument, it can come out sine of 15 degrees. Okay. And so now we're back to the same old thing with the 15 degrees. We have 30 degrees over 2. So this is equal to, well, what does the formula say? It's minus, okay, and what is this going to be? Well, that's going to be square root, so it's either plus or minus. It's the square root of 1 minus the cosine of 30 degrees over 2. Okay? Now, how do I know if it's the plus or the minus? Well, a 15-degree angle, all students take calculus, so that's actually going to be positive. So we got the positive going on here. Okay? So, but then the negative on the outside from our odd property, that's going to make it negative later, but this is, how we determine if the plus or minus for a square root. And so same thing here. I have 1 minus, instead of plus, it's a minus, and it's square root 3 over 2 divided by 2, all square rooted. And so this becomes 1 half minus square root 3 over 2, actually over 4, and get the common denominator like we did last time, 2 minus square root 3 over 4, and then when I reduce, I get square root 2 minus square root 3 over 2. Okay. All right. So let's do one more. And we have find the exact values using half angle formula if the cosine of alpha equals negative 3/5. Okay, so the cosine of alpha is negative 3/5. And then we have alpha between 3 pi over 2 and pi. So it's in the third quadrant. And so I've got, first one I want to do, A, is sine of alpha over 2. B is the cosine of alpha over 2. And C is the tangent of alpha over 2. Okay? All right. So for the first one, okay, so first observe that we've got alpha in from pi to 3 pi over 2. Okay? So if that's the case, where's alpha over 2 going to be? It's going to be from pi over 2 2, 3 pi over and divide 2 by 2. That gets you 4. Okay. As a result, where does alpha over 2 lie? Well, now it's going to be in that second quadrant. So from here to here. So Q2, right? So so all students take calculus. So sine is positive in Q2. So that's positive. This is negative. This is negative. Okay, so we know that right off the bat without doing anything. We know that the first one's going to be positive, and then cosine and the tangents are going to be negative. Okay, so let's draw our picture. So we know we're in Q2. Now alpha, our triangle, is cosine. So cosine alpha equals negative 3 over 5. Now cosine is x over r. Now x in the second quadrant is negative, so x has to be negative 3, and r has to be 5. So that's negative 3, and that's 5. So I need to figure out what that opposite side is. So y squared plus negative 3 squared equals 5 squared. So y squared plus 9 equals 25. Subtract 9 from both sides, I get 16. And so y is equal to plus or minus 4. Well, in the second quadrant, sine is positive, so that's a positive 4. Okay, go up 4. All right, so now I have the tools that I need. Okay, and once again, this is for my alpha over 2. Sorry, that's my alpha. Oh, wait a second. Wait a second. Okay. Yeah, we're okay. We're okay. So we actually didn't even need to do this. Got ahead of myself. If I want to find the sine of alpha over 2, okay, what is this equal to? Well, the formula says that's the square root of 1 minus cosine alpha over 2. Okay? So then what? So I know that the cosine of alpha is negative 3/5. So this is a square root, and it's the positive one because sine is positive in the second quadrant. 1 minus, and then minus 3/5 over 2. So minus and minus makes a plus. So that becomes 1 plus 3/5 over 2. So this gets me 8/5 divided by 2, which is square root 4/5, which is 2 over the square root of 5, which if you multiply top and bottom by square root 5, I get 2 square root 5 over 2. I'm sorry, 2 square root 5 over 5, rather. Okay. Now for the b, for the second part, cosine of alpha over 2, this is a square root plus or minus, and it's 1 plus cosine alpha over 2. Now this one happens to be negative because we're in the second quadrant. So we're going to do negative square root 1 plus, now cosine alpha 3/5, negative 3/5 over 2 here. So minus, and then now 1 minus 3/5 gets me 2/5. So that's minus square root, and then that's 2/5 divided by 2. That gets me 1/5. So I have negative 1 over the square root of 5, which simplified is negative square root 5 over 5. Okay. And then C is the tangent of alpha over 2. Now tangent is square root, so it's plus minus, and it's 1 minus cosine alpha over 1 plus cosine alpha. So tangent is negative in that quadrant. So it's negative, so that means it's minus square root 1 minus and then negative 3/5 over 1 plus negative 3/5. Okay. And so whenever I run through all of that arithmetic, in the numerator I'm going to get 8/5. In the denominator I'm going to get 2/5. Keep, change, flip. And I'm going to get 4. And so the square root of 4 is 2. So I get that -2 for my answer. Okay, that might have been a little confusing for you, but you know, another way with tangent of alpha over 2 is equal to the sine of alpha over 2 divided by the cosine of alpha over 2. Okay? So we found the sine and the cosine. The sine was this, or you could, have that. So 2 over square root 5. And then the cosine was -1 over square root 5. Well, square root 5's cancel, right? It's 2 over square root 5 times -1 over square root, keep, change, flip. Square root 5 over 1. And those cancel and you get the -2. So same desired result. Okay, so several ways to work through this. The half angle formula for tangent of 1/2 of alpha, this is equal to 1 minus cosine theta, or cosine alpha, over sine alpha. And another way to write it is sine alpha over 1 plus cosine alpha. Okay? So that's just one more way that you could write the tangent. So the half angle formula for tangent. Okay. And so with this one, if you knew that the cosine of alpha was equal to -3/5, and then alpha was between pi and 3 pi over 2, then the sine of alpha, sine of alpha. Now, sine in the third quadrant is negative, and square root 1 minus cosine squared alpha from the Pythagorean theorem, right? So sine squared x plus cosine squared x equals 1. If I solve, I move cosine squared x over, I get 1 minus cosine squared x, and then a square root, I get a plus or minus. Well, I know it's a negative because we're in Q3. Q3, the sine value is negative. Okay, so sine is negative in Q3. Okay, that's where that came from. And then if you know what cosine is, cosine of alpha, 1 minus and then -3/5 squared. So squaring it makes it positive. So this is minus square root 1 minus 9 over 25, which makes it minus square root, and then 1 minus 9 over 25 is 16 over 25. When I square root that, I get 4 over 5. So that's minus 4 over 5 for sine alpha. Okay, you could have done that from Pythagorean triangle trigonometry. But then we can utilize our formula here. Okay, 1 minus cosine alpha over sine alpha is equal to 1 minus 3/5. Okay, and then minus a 3/5, and then minus 4/5 in the denominator. Minus a minus makes a plus 3/5 over negative 4/5. And then this gets us 8 over 5 divided by negative 4 over 5, which gets me negative 2 again. So just one more way to work that last problem there. Okay, so giving you tools that you have. This one's good because, it doesn't contain that plus or minus sign. So it kind of eliminates that one step for this last formula right here. All right, well, that's the end of this video.